Hi everyone, it's Adam again. It's been a while since I've done the last video, so I'm just going to pick up where I left off. So today I'm going to go over what a discriminant is. So a discriminant is what's under the minus b formula. So when you have x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. The discriminant is this thing under the square root. Okay? So this is basically how we tell if there are real roots to a quadratic equation or not. Okay? So for example, if b squared minus 4ac is greater than 0, so basically if you're taking the square root of a positive number, you get two numbers. So you have two real roots. You'll get something that will look like this. Either your quadratic will look like this, where that's root number 1 and that's root number 2, or it'll look something like this, where that's root number 1 and that's root number 2. Okay? But it's just to say that if in an exam and they ask you and they say, okay, show that this equation has real roots, all you have to do is show that this is greater than 0. Okay? Now, if you have that your b squared minus 4ac, sorry, again, remember, just as a recap, for the minus b formula, it's for ax squared plus bx plus c equals 0. So that's what this formula is used for. So the b and the c and the a correspond to the coefficients, or the number of x squareds, x's, and constants you have. Okay? If b squared minus 4ac equals 0, then your graph should look something like this, where it'll just touch the axis at one point, or it could also be facing downwards. So something like that. Okay? So here we say that it has two real roots still, just that the two roots are equal. Okay? You can probably imagine, because if I go up here and this part is 0, then I'm just left with that the root is minus b over 2a. Okay? And then if b squared minus 4ac is less than 0, now we have a negative number under our square root, which basically means we have no real roots, and therefore the quadratic equation will look something like this. Or this. So it's just that if you have your b squared minus 4ac is less than 0, then the quadratic always lives above or below the x-axis. Okay? So hopefully that's all okay. So now if we do something like this. So it says in the question here, it says find k if x squared plus 6x plus k has two real equal roots. So what they're asking is, they're looking for this case when there's two roots but they're equal, so they just touches off the axis. So you don't have two distinct roots or two different roots, you have the same one. So in this case, we're looking for the b squared minus 4ac to be equal to 0. So in this case, a is equal to 1, b is equal to 6, and then c is equal to k. So again, I want b squared minus 4ac to equal 0, or I want b squared to be equal to 4ac. Okay, so I want 36 to equal 4k, so k has to equal 9. And so if I were to draw this now, this means that we get x squared plus 6 and x plus 9. We would get something like this. So it's positive because you have 1x squared, so that's greater than 0, and therefore it's a positive facing quadratic. and your double root here is -3. Okay, you can check that using the -p formula if you would like. I'm just doing this, in my head just to make time a little bit faster. Okay, so that's all that is. Okay, so hopefully that's all right. So now we can also have something like, for what values of p does 2px minus px plus 1 equal x squared plus x have real roots? So again, real roots, that means either you have two different roots or you have the same root twice. So we want our b squared minus 4ac to be greater than or equal to 0. So we can have two different roots or we can have the same root. Okay, so just be careful. So in this case, if I bring this over to the left hand side, I get x squared into 2p minus 1 plus x into minus p minus 1 plus 1 equals 0. So again, a is 2p minus 1, b is minus p minus 1, and c is equal to 1. Therefore, if I do b squared minus 4ac, I get that it's going to be minus p minus 1 squared minus 4 times a, which is 2p minus 1, times c, which is 1. So this gives me p squared plus 2p plus 1 minus 8p plus 4 has to be greater than or equal to 0. So I get p squared minus 6p plus 5 has to be greater than or equal to 0. Now, for these ones, always what you do is you solve for equal to 0, because what I can do is I can solve for when it equals to 0. I can draw the quadratic and then basically say, okay, well then what value does p need to be for me to be above the x-axis, so greater than or equal to 0, and then what value is below. So it'll become very obvious in a second, but I'll just do it anyways. So if I factorize this, I get p minus 5, p minus 1. So when does this equal 0? This equals 0 at p equals 5 or at p equals 1. So now if I draw it out, p equals 1 is here, p equals 5 is here. The quadratic is positive, again, because you've 1 p squared, so the 1 is positive. So it looks something like this. So again, so what is it I want? I want this thing to be greater than or equal to 0. So I want these values and these values. And they correspond to this and this. Okay. So we have that p needs to be, so again, this is 1 and this is 5. So p needs to be less than or equal to 1, or p needs to be greater than or equal to 5 for 2 real roots. Or you could also say that p has to be greater than 1. Sorry. P has to be less than 5 and greater than 1 for no roots. Because here, this is where you would have no roots. So up here, you have roots. Here you have roots. And then in the middle, then you have no roots. Okay? So hopefully that's all right. The very last thing in this one is inequalities when it comes to proofs. So for an inequality, basically what you're kind of looking for is you're looking to have something real squared and you want to show that it's greater than or equal to 0. This will become very obvious in a second. Basically, the main thing that you need to know is they might say show that a squared plus b squared is always greater than or equal to 2ab for any a and b element of R. So show that this is always the case, no matter what, basically. So what you do is, you want it to look something like this. So first of all, I'm going to bring this over to the left-hand side. So I'm going to get a squared plus b squared minus 2ab is greater than or equal to 0. Now I'm just going to rearrange it a little bit. So it's a squared minus 2ab plus b squared is greater than or equal to 0. This is actually your formula for a minus b to b squared. And therefore I proved it. Okay? So that's all. Okay? So hopefully that's alright. Because some of these can be quite difficult. Okay, but this is like the main idea. You want to just be able to square something on the left. The reason is because if I get something and square it, then it has to be greater than or equal to 0. Plus by plus is plus, minus by minus is plus, 0 by 0 is 0, and therefore anything squared is always going to be greater than or equal to 0. The smallest thing you can have is 0. Okay, I might do one more. But yeah, so we can do yeah, I think I can do this one. So it just says that show that p squared plus 1 is greater than or equal to 2p for p element of R. So again, just for any p, so any p you can think of. So 17 minus 2.37, whatever, just all ones. Again, bring the 2p over, I get p squared minus 2p plus 1. That's just going to be p minus 1 to p squared is greater than or equal to 0. Okay? All right. Okay. Now, so another thing we have is that I can prove, so I'll just prove this one and then I can leave it there for today. So you have a squared minus b squared has to be greater than a minus b to b squared. Now there is a little bit of a subtlety to this. Okay, so you have that a is greater than 0 and b is greater than 0. Now they don't say it in the question, but you also obviously need a to be greater than b. Why? Because here we have a squared minus b squared. That's greater than this thing, and we know that that's always greater than or equal to 0 because this thing is just squared. And therefore it has to be greater than or equal to 0. Therefore a has to be bigger than b because a squared must be bigger than b squared. Okay? That'll come in important in a second. So a squared minus b squared, I can factor that into a minus b and a plus b. Has to be greater than a minus b to b squared. Now I can divide both sides by a minus b. Minus b, and then this simplifies down to that b is greater than minus b, which is true because b is greater than 0. Okay? Now just before I finish the video, does anybody have a problem with what I just did? Specifically in this line? Because you should. I just divided by a minus b on both sides. Why am I allowed to do that? You're allowed to divide by anything so long as what you divide by is greater than 0. And a minus b is greater than 0 because a is greater than b, as I said up here. Okay? So this only works because a is greater than b. Okay? Because remember, if you have 1 is greater than minus 1, you can't just multiply everything by minus 1 because then you get minus 1 is greater than 1. So if you multiply by a minus, you need to change the inequality. So this sign must flip. So again, I covered that in a previous chapter, but just, just to reinforce that, there's always some subtleties to these things that you can mess up very, very, very fast. So yeah, I think I'll leave that there for today. So hopefully that's all right. So yeah, thanks very much for listening, and I think I'll leave it at that.